What we're doing here, we're just applying the air where it's actually needed. So the load is at this end of the room. So these units up here, they're still running at their fan management speed and volume. And the further I get away from the load, the less airflow I need to do. So what these units are basically doing is maintaining the set pressure in the floor. The easy way to do that is our raised floor pressure management system.
My name is Mark Ebert. I work at Stulz, Australia. I'm a technical solutions engineer. I've just completed a presentation on airflow management in data centers. The issue there was to create an effective and efficient airflow management in the data center, so to save energy and to create a better environment for the server equipment. So the issues that were discussed were the requirements for the service equipment and the inlet to the equipment. Then we went on to discuss rack and room layout. So getting that temperature, correct temperature to the rack itself, and how the room layout actually affects the airflow in the server. After that, we looked at the fan management system that we have standard in our units, and as an option, the raised floor pressure management to be used to save energy. So there are different types of airflow management. The traditional layout in a computer room is a hot air cold aisle system, which can lead to inefficiencies because there's a lot of airflow mixing going on. In the future, what is happening now is to go to containment solutions, and there are many different solutions. They go from like a cold aisle containment solution, where you have a traditional rows of racks, and the cold aisle is contained, so the cold air can only go through the servers, not get mixed with the hot air. To hot air containment, to cold air containment, so the air actually goes up into the rack from the bottom, with a solid front door on the rack. So that's like an inbuilt cold air containment but on the rack level. In that way, they're very easy to implement, because you don't have to change it either way. Data center. So where we're now going to is to containment solutions, and there are many different containment solutions. Stulz works with all of them, basically, so we're not linked into any single one. And that goes from like a cold aisle containment, where I'm actually closing the whole cold aisle with doors and with a roof, which can be retrofitted in existing centers, but it's often difficult because they're often there, the racks are different levels, so that's often quite difficult to do. Other solutions are like a cold air containment on the rack level, where I have air entry going into the rack from the bottom, and with a solid front door, so the air is contained at the front of the rack. The servers will only get cold air, so there's no air mixing front. The advantage is that's on a rack level, so I can just have just a couple of those in my data center if I need to, or roll them out over another time without having to change my whole data center. There are other solutions like hot air containment or ducted racks, where I'm actually taking the hot air from the back of the rack and up into a return air planner. So again, I'm separating the cold air and the hot air side. The advantage of those is that I gain a lot of efficiency. My cold air is not contaminated with the hot air temperatures, and the opposite, my hot air is not contaminated with my cold air. So I can operate my precision cooling units at a much larger temperature differential than it would otherwise. And that has a couple of effects. One is that it saves fan power. So I'm actually only using as much air as I really need for my server equipment. And I can also normally raise my temperature levels. both from the supplier and the returner level. So that, again, will also make my precision cooling unit cool. These very simple steps, we can save a lot of energy. And of course, energy costs are increasing, as we all know, but pretty quickly, unfortunately, as you can tell from my bill. But there's also big advantages, obviously, in greenhouse gas savings, which is another thing that not necessarily a cost impact, well, not at the moment, but there's an environmental benefit there. So both of these, all this airflow management will aid lower costs and also reduce greenhouse gases, but also will actually create the best possible conditions for my server equipment, which is my main purpose of this thing. Like any kind of containment solution where the cold and hot air streams are mixed, as I said, that generally will mean that my return air will be warmer. What that means is that will make it much more effective in a free cooling application. We have a number of free cooling methods that we can use at Stulz, and any of those will be much more effective and therefore cost effective when used with a proper airflow management system. So that will again multiply my benefits, not only from the existing fan power and vacuum installation, but also make my free cooling systems much more effective. I think one of the most important things is that even with small data centers or existing data centers, things can be done to improve the situation. You don't have to build a whole new data center to implement some of these things that we've discussed. And they start from very simple things like blanking panels to replacing the single racks, which is really not that much a big deal, or localized containment solutions where that's possible, cost effective. So I think what we're trying to do is to encourage people not just to say, oh look, I've got this data center and I know the setup is really useless and I can't do anything about it. What we're trying to say is, well, you can do something about it, and we can help you do it. Data centers need humidification. What tends to happen in places where there's a lot of heat load is that the air dries out a lot. So what we need to do is we need to add humidity, add in moisture to the air, to stop the air drying out and causing problems with electrostatic discharge. So we've also got to understand that other people have been interested in that. So the way it works is two transducers that vibrates at very high speed. They create a column of water inside these chimneys. At the edge of that column of water, very fine water droplets are produced. As I said, this is a mechanical process, so we're not heating up the water like an immersed electrode humidifier. It's actually a mechanical process without adding any heat. So I'll just turn that on. We've got these fans over here at the back which carry the moisture away. So here we can see the droplets being produced. It's actually wet. Within a certain distance, these droplets actually evaporate in the air, and they humidify the air in doing so. These fans, as I said, are built in this model to carry the moisture away. Normally these would be installed in a duct. We also have a model that can just be wall mounted separately. The advantage is it's very low energy consumption, uses only about 5% of the energy of a traditional immersive electrode system, and it's also very easy to control. It goes off on and off instantly, and it has also got part load characteristic controls. As you can see here, so it's just operating on part load. It's getting near the set point, it's just going on and off. The transducers are being pulsed on or full load.